Hello, thank you for watching my presentation. Today I'm going to be giving my presentation on Algebra 1 SOL scores in post-pandemic Virginia. Now, Algebra 1 SOL stands for Standards of Learning, and that's the test that's taken at the end of Algebra 1 courses in the state of Virginia, and that is a form of standardized testing that we use here. So during the COVID-19 pandemic, public schools were closed in Virginia, and this led to a significant drop in standardized test scores. However, in the years following the reopening of schools in 2021, math test scores have steadily risen, but they still lag behind pre-pandemic levels. So what I wanted to find was which areas of Virginia saw the most improvement during this 3-year period. Were there any areas in the Commonwealth of Virginia that fell further behind, and why? And what were the factors that led to that? So in Virginia, statewide standardized testing is given at the end of courses, and these standardized tests are called SOLs. SOL is simply an acronym that stands for Standards of Learning, and the test is scored from 0 to 600, with 600 being a perfect score and 400 being the passing threshold. Algebra 1 is a course at the high school level, but it's also taught at the middle school level, and it's separated into a fall course called Part A and a spring course called Part B. And the SOL test is administered at the end of the Part B course in the springtime. So for this study, I'm going to be using a population size of 129 school divisions with 94 counties and 35 independent cities that aren't a part of any county. So for example, if I was talking about Roanoke, Roanoke is an independent city in Virginia, but it's not part of Roanoke County. So the population used in this study could be extrapolated as a sample for a larger population in the United States or for another state. So the pre-pandemic statewide results for the Algebra 1 SOL are summarized below in the graph. In 2017, our pass rate was 82%, and in 2018, our pass rate was 81%, so it fell by a percentage point. And by 2019, our pass rate was 86%, which would be its high. Now, here's a note about pandemic statewide results. Statewide results for 2019 and 2020 aren't available on the website due to the closure of schools and the cancellation of state assessments. Statewide results for 2020 to 2021 reflect reduced student participation due to COVID-19 and other pandemic-related factors. So I had a hard time finding data on the Department of Education website. So variations in participation rates and learning conditions should be considered when you review the 2020 and the 2021 test data. So for the post-pandemic statewide results, those are summarized below in the graph. In 2022, the pass rate was 80%, and in 2023, it went up to 82%, and in 2024, it rose 3 percentage points to 85%, so steadily increasing over the 3-year time period. The average pass rate for the 3 post-pandemic years is 82.64%. Lexington had the highest pass rate in the state at 99%, and Charles City County had the lowest pass rate at 47%. And Franklin County is the closest to the average pass rate at 82.67%. And you can see that in the graph below. The average improvement rate over those 3 years is about 5.81%. Galax was a city that had the highest improvement rate at about 59.68%, and Scott County had the largest decline at a rate of negative 20.45%. And Chesapeake was the closest to the average improvement rate at 5.75%. So here in this graph, you can see that there are more divisions that improve than decline. The biggest population centers in Virginia are located in the Tidewater region in the southeast, and the Richmond metropolitan region in the center of the state, and in the DC metropolitan region in the northeastern part of the state. And the lowest populated areas include Southwest Virginia, which is close to West Virginia, and Southern Virginia, which borders on North Carolina, and Eastern Virginia and the peninsulas in the eastern part of the state. So here you can see in the map that the region in the top right-hand corner that is in the light blue is northeastern Virginia, and that includes Fairfax, Loudoun County, and other wealthy counties that border DC. And you could see in brown, you have the Eastern Virginia counties, such as Caroline and King William County. And you could see that there is Richmond, the capital of Virginia, which is in pink. And the green counties are make up central Virginia. And you could see that the Shenandoah Valley is in red. And that includes counties such as Highland County, Bath County, and counties that tended to score pretty well on the SOL test. And you can see in yellow, we have the counties and cities that make up Southern Virginia that border North Carolina. And the blue counties that are below the Shenandoah Valley are considered part of the Blue Ridge Mountains. So you could see Franklin County, Botetourt County, Giles County are all part of the Blue Ridge Mountains region. And last but not least, you can see on the left side in orange, those are the counties that make up Southwest Virginia. And that's the region of Virginia that tended to have the highest pass rates of all. So you could see in this chart that the average pass rate is in the middle, and Southwest Virginia had the highest average pass rate, and Southside Virginia, also known as the Richmond metropolitan area, had the lowest average pass rate in the state. And on the right side of the graph, you can see the improvement rate. The Blue Ridge Mountains region had the lowest improvement rate out of the entire state, but Southern Virginia had the highest improvement rate at about 10.72%. In terms of cities versus counties, counties tended to have higher pass rates than cities in general, and the difference did turn out to be significant. So when I performed a t-test for the pass rates, I found that the difference between the county pass rate and the city pass rate is significant with 98% confidence. And cities tended to show greater improvement than counties did. However, the difference between the improvement rates is not statistically significant. And here in this graph, you could see that the cities are on the left side of the graph and the counties are on the right side. And the cities tended to have higher dispersion in their average pass rates. So you had some cities that scored very low, but you also had cities that scored very high. And the county pass rates tended to be locked in a certain range. But obviously, you could see that one county in particular, Charles City County, had a pass rate that was near 45%, which is at the bottom. The improvement rates for cities and counties are on this graph. And here you could see that the improvement rate for cities was a lot better than it was for counties. And these explanatory variables can help us learn what actually affected the pass rates and the improvement rates. So these explanatory variables can help explain why some divisions had higher pass rates than others, and why some areas of Virginia were able to improve at a higher rate than others. So when we look at pass rates, we see that classroom grades had the highest effect on the pass rates, followed by race and chronic absenteeism. And some factors, such as college degree attainment in the population and student teacher ratio, didn't really matter much when it came to pass rates. And for improvement rates, the most important explanatory variable turned out to be race, followed by the percentage of students with disabilities in the school population. And internet access also happen to be very key for improvement rates. So, like I said before, Northeastern Virginia has the highest population because of its proximity to Washington, D.C., and Eastern Virginia has the lowest population in Virginia. And when you look at population as it relates to the average pass rate, there tended to not be much correlation between those. And when you looked at improvement rates, that also tended to have no effect when it came to population. When it comes to median household income, divisions in Northeastern Virginia report the highest median household incomes because you have a lot of wealthy counties such as Loudoun County and Fairfax County tipping the scales in that direction. And divisions in rural Southwest Virginia reported the lowest median household incomes. But your median household income didn't have much effect when it came to average pass rates, and it didn't have much effect when it came to improvement rates either. Southwest Virginia and Southern Virginia are the regions that tended to have the highest poverty rates in Virginia. And you'll see that Northeastern Virginia has the lowest average poverty rate. And you can see that the poverty rate, according to the average pass rate, had a very weak negative correlation in the sense that the more poverty you have in a region, the lower their average pass rate was. But it wasn't statistically significant. And I found that the poverty rate didn't have much effect on the improvement rate of a region in Virginia. And when it came to SOL participation rates, there was very little variation in how many students participated in the SOL. Most, if not all, of the students at the end of a course take the SOL, unless they are taken out by parent permission. So there's very little variation in these participation rates, and they didn't have much effect when it came to the average pass rate. School divisions in Southwest Virginia tended to have the highest percentage of white students, and you could see that the Tidewater region had the lowest percentage of white students in Virginia. And this does have a consequence when it comes to average pass rates. You could see that there's a moderate positive correlation between the white percentage and the average pass rate that a region had. So you could see that the higher the white percentage is, the higher the average pass rate was. So this is considered to be statistically significant. And in the other direction, the higher the white percentage of a county, the lower their improvement rate was. And you could see that in this graph. Students with disabilities make up the disability percentage in a region, and this includes students with IEPs and 504 plans. And the region of Virginia that has the highest population had the lowest percentage of students with disabilities simply because of that high population. And Southwest Virginia had the highest percentage of students with disabilities. However, this didn't really have much effect on the average pass rates, as you could see, and it didn't have much effect on the improvement rate either. But you could see that there's a very weak negative correlation between the disability percentage and the improvement rate, and that the higher the disability percentage was, the lower the improvement rate of a county was. Now, chronic absenteeism is very important. Chronic absenteeism is defined as missing more than 10% of the school year, which is 18 days for any reason. And that includes excused absences, unexcused absences, and suspensions. Southern Virginia tended to report the highest rates of chronic absenteeism in the state, while the Tidewater region reports the lowest amount of chronic absenteeism. Chronic absenteeism does have a significant effect on the pass rate of a county or city, as you can see in this graph. As you can see, the higher the chronic absenteeism is, the lower the average pass rate of a county or city was. Now, school divisions in the northeastern part of the state have the highest student-teacher ratios because there's just less teachers to go around for that many students. But the good news is that student-teacher ratios didn't have much effect on test outcomes as we like to think. Eastern Virginia tended to have the lowest average student-to-teacher ratio, but even then, that didn't really have much effect, as you can see in this graph. The two variables don't have any correlation whatsoever. Southwest Virginia tended to spend the lowest amount on students when it comes to division funding, and yet that region had the best outcomes in terms of SOL scores. But it didn't have much effect on the average pass rate when I looked statewide, so there wasn't much correlation between division funding and test performance. Now, school divisions that had better internet access tended to show higher improvement on the SOL test, and that may be because the counties of northeastern Virginia have much better internet access than more rural regions, such as southwest Virginia. And northeastern Virginia did tend to show higher improvement rates than southwest Virginia, even though southwest Virginia have higher overall scores than northeastern Virginia. So you could see in this graph that there is a very weak positive correlation between internet access and the improvement rate of a county. Now, you may think that college degree attainment may make some difference in test scores. Northeastern Virginia has the highest percentage of college graduates, while the rural Southwest Virginia region has the lowest percentage of college graduates. So when I looked at the linear regression, it turned out that there wasn't much correlation between college degree attainment and test performance. And when it comes to unfilled math teacher positions, the Tidewater region tended to have the highest number of unfilled math positions, and the Blue Ridge Mountains tended to have the lowest number of unfilled math teacher positions. There is a very weak correlation between the unfilled teacher percentage and the average pass rate, in the sense that the more unfilled math teacher positions you have, then the lower the scores would be when it comes to SOL testing. So, in the past few years, there has been something called the Comprehensive Instructional Program formed, and that is a consortium of public school divisions in Virginia that collaborate to improve test scores and instruction by using a unified curriculum. And you can see in this graph that the counties and cities that are shaded in purple are a part of CIP. So all those cities and counties have the same curriculum when it comes to Algebra 1 instruction. Now, I found that CIP school divisions had higher pass rates than their non-CIP counterparts, but CIP school divisions did have lower improvement rates than non-CIP school divisions. And you can see in this chart that the counties and cities that join CIP on average have lower populations than the non-CIP counties. They have lower incomes, they have higher poverty rates, and they tended to have more white students than non-white students. And their disability percentages are higher. They have higher chronic absenteeism rates. However, they did score higher on Algebra 1 tests than their non-CIP counterparts. So then, with all these factors, what I wanted to do was see how they interacted with each other in a model. So I decided to use multiple regression to help me. And this is a statistical technique that uses several explanatory variables in order to predict the outcome of a single response variable. So I could take independent variables such as poverty rate, chronic absenteeism, white percentage, and see how that affects the overall average SOL pass rate of a region. So when I use multiple regression, I put in all my variables at the same time. And when I do that, This is called a saturated model because it took all the variables into account. And when I did that, I found that chronic absenteeism has the most significance when all variables are considered. So when I ran the code, I got these results, and you could see that the variables are on the left side of the screen, and the estimates are the coefficients of the variables in the model. Now, looking at the PR, that stands for probability, and the lower that number is, that meant that the variable was more significant to the model. And you could see that some variables have more stars than others beside them. And the more stars that a variable has, the more significant those variables were to the model. So you could see that chronic absenteeism, when everything is taken into account, had the most effect on test scores. But you could also see that the white percentage and the Tidewater geographic region and the city versus county variables, they all had a significant effect on the model. So for pass rate model interaction, I wanted to see how different variables interacted with each other. So I ended up multiplying variables together and using those as my new variables in the model. So looking at this, there is considerable interaction between the white percentage variable and the city versus county variable. And that makes sense when you think about it because a county in Virginia would have a higher white percentage than a city would, for example. So it does make sense that there would be considerable interaction between those two variables. And you can also see that chronic absenteeism and the white percentage also interacted heavily with the Shenandoah Valley region, which is SV in my model. And the TW in the model stands for the Tidewater region. So those variables were very significant in the interaction model. And when we add or remove variables from the model, we may find that the resulting model fits the data better. And this is called a stepwise regression. So we could remove variables, and that is called a backward step regression. But we could also add variables to the model, and that's called a forward step regression. But what I tended to use in this project was the best subsets regression. And what that does is it tests the model for all the subsets of different variables, and it chooses the best subset of variables that had the most effect on pass rates. Now, according to this table, the model with the 8 variables had the highest adjusted R squared value and the lowest AIC value, which means that it's the best fitting model for the data. In general, the higher your R squared value is, the better the model fits the data. So I used those 8 variables and I ran the model again, and I got this result. So this is the best pass rate model according to the best subsets regression. And the model indicates that the CIP variable and the white percentage variable and chronic absenteeism are all very significant when it comes to pass rates. So then what I did was I wanted to see what variables had the most effect on the improvement rate of a city or county. So this is my saturated model, and the model shows that there is a star beside the geographic region of Southern Virginia, and that indicates that the Southern Virginia region had a very high improvement rate when compared to other regions, such as Southside or Southwest Virginia. And when I ran the interaction model, I found that there was considerable interaction between the Shenandoah Valley and the white percentage variable. So that's what that star means. So when I ran the best subsets regression, it turned out that the model with 5 variables maximizes the R squared value and minimizes the AIC value. And that indicates that that model fits the data the best. So using those 5 variables, I ran the multiple regression model again, and I found that that was the best model that fit the data. However, the adjusted R squared value was very low for this model, which indicates that this model is not a good fit for the data. And I'm not sure that the data has a very good model to go with it. But for this one, it turns out that the white percentage had the most significant effect, followed by the internet access of a region. So to further study the data, I decided to use k-means clustering. And what that is it's a machine learning technique that's used to cluster data points together based on similar attributes. The way that it works is each data point belongs to the nearest mean, and that's called the centroid. So the centroid is the center point of a cluster. And what we want to do is we seek to minimize the distances from each point to its centroid when we do k-means clustering. So to do it, the data in the spreadsheet has to be standardized first. So to do that, I took the numerical data and I used the scale function in R to standardize it. And if you remember from statistics, this is the same thing as assigning a z-score for each data value based on the value, the mean, and the standard deviation for each variable. So once all the data was standardized, I added all that data to a new data frame using the Columbine function, and then I used the k-means function to perform k-means clustering. So for this code, the 2 was the number of clusters that were initially chosen, and the number of iterations that the algorithm went through was assumed to be 10 to start off with. And the 25 is the number of random starting positions for the algorithm. And to view the cluster that each school division was assigned to, I used the function $cluster. And what that did was it showed the number for each school division. So that means that the first school division in alphabetical order, Accomack County, was assigned to cluster 2. And then the next school division, which is Albemarle County, was assigned to cluster 1, and so on. Now, to find the optimal number of clusters, I use the elbow point method. And that helps us to choose the number of clusters we want to use. And we want to limit the overlap between the clusters, but we also want to have enough clusters to perform a decent analysis on them. And in this case, if you look at the graph, the elbow point is the point where the arm transitions to the lower arm, so to speak. So the elbow point was found at 4. So I decided to use 4 clusters for my data set. So here's the cluster plot that I found. And you can see that cluster 1 is in red on the right side, and that is comprised of the Northeastern Virginia divisions. And there's not many of them, and they tended to have the same statistics in terms of median household income and poverty rate. So those tended to be in a cluster on their own. And you'll see that there's a green cluster, and that is cluster 2. And that tended to contain divisions with median characteristics. The cluster 3 in blue contains divisions with low pass rates, but high improvement rates. So these were counties and cities that had low pass rates, but also tended to improve very well once school got started up again. And you'll see that at the top left, you'll see this cluster in purple, and that is cluster 4. And that contains school divisions that are in rural parts of Virginia. And these school divisions tended to have high pass rates and low improvement rates, such as those that were found in Southwest Virginia. So I found that cluster plot to be very interesting in terms that it helped me organize my data into a good visual. So when I performed cluster analysis, I wanted to find the average poverty rate for each cluster, and I wanted to find the white percentage, the chronic absenteeism, and the pass rate and improvement rates in each cluster. So you could see that in cluster 3, they tended to have high poverty rates, but they also tended to have low pass rates, and high improvement rates. So that led to the question, do higher poverty rates lead to higher test scores? So when I looked at cluster three, I found that the school divisions that had higher poverty rates tended to have higher pass rates on the Algebra 1 SOL. Now, this isn't statistically significant, but it is very interesting. And this also tended to work the same in cluster four. In cluster four, you have a bunch of rural counties that tended to have high pass rates. So you could see that in this cluster, the higher the poverty rate was, the higher the average pass rate was, which I found to be very interesting and worthy of further study. In addition to k-means clustering, I also decided to use hierarchical clustering in order to organize the data. Hierarchical clustering is a lot like k-means clustering in that it is a machine learning technique that organizes data into a tree of nested clusters. And the method that I decided to use was Ward's method, and that resulted in four similar clusters. So you could see that this broke off into two main branches. There is a left side and a right side. And you could see in the right side, there is a cluster right here that breaks off rather soon. And that is cluster one in northeastern Virginia. So you could see that these school divisions are right here in the first cluster. And right beside it is cluster two. These are the cluster of school divisions with median characteristics. And you could see on the left side, I also have two clusters. You could see that there is cluster four right here, and you could see that cluster three is right here beside it. So in conclusion, the most important factors that affect a school division's Algebra 1 pass rate are classroom performance, how they do in class, chronic absenteeism, the student's attendance in class, and the race of the students. Those three factors tended to affect the pass rates the most. Southwest Virginia has the highest pass rates in Algebra 1, and I think that's due to a combination of factors, such as low chronic absenteeism, the low percentage of non-white students, a more homogeneous base of students, and a streamlined curriculum with a comprehensive instructional program. And other factors like student-teacher ratios, college degree attainment, and poverty rates, those were long thought to have influenced classroom success and test performance. However, in my study, they turned out to not have been so important when analyzing the results. And in fact, like I said before, in some of the more impoverished parts of Virginia, such as rural Southwest and the Richmond metro area, higher poverty rates are associated with higher pass rates in general. And rural regions such as the Southwest Virginia, Blue Ridge Mountains, and Shenandoah Valley, those regions have joined CIP in order to improve their pass rates. So they do tend to have better pass rates than school divisions that did not join CIP. But I think this may be due to other factors such as chronic absenteeism and race. And due to the significant impact that the program has had, more school divisions may benefit by joining CIP. But overall, the school divisions in Virginia have shown remarkable improvement since the COVID-19 pandemic, which shows the importance of showing up for school. Southern Virginia, in particular, has shown the most improvement, and this is probably due to their high chronic absenteeism, their high number of non-white students, and higher rates of poverty in the region. CIP school divisions showed less improvement overall, but that may be to other confounding variables, and that's worthy of future study. So at the end of the study, I didn't have much info on classroom performance and how grades affected test scores. So I reached out to one of my colleagues to get classroom grade data from school divisions that belong to CIP. So this data is only based on 51 cities and counties in Virginia. So take that into consideration. But when we ran the model, we found that the average classroom Algebra 1 grade had a very low probability value, which indicates that it was the most significant factor overall when determining SOL scores. So classroom grades tended to be very good predictors of SOL scores. And you could see in this slide that chronic absenteeism is also very important when it comes to SOL scores. And school divisions in rural parts of Virginia tended to have lower numbers of college graduates overall. And that's probably why a limited number of college degrees would indicate a higher test performance. So, lastly, I have this data from 600 students at Halifax County High School in Southern Virginia. And the data indicates that there is a very strong correlation between the Algebra 1 classroom grade and the end of course SOL score. So you could see that there is a very, very good correlation between those two variables. So thank you so much for watching my presentation. I had a lot of fun doing the research for it, and I hope you enjoyed it as well.